Hey everybody, welcome to my channel. Today I'm going to be working on a CNC wood carving for my son's room. We're going to take a Viking STL file, bring it into VCarve, and cut it out on the CNC. So come along for the journey, watch me make a few mistakes. That's what I'm here for, and hopefully we'll learn something by the end. Okay, over here in VCarve, I'll just kind of show you my project here. I took a vector from ChatGPT. Actually, I just had it render or create the STL vector for this Viking, and it gave me the STL vector, and then I brought it into Blender 3D. And then extruded each section based on some variation in heights from the front to the back, or what I consider to be front to the back. So like the chin is lower than the beard and mustache, for example, and this forward horn is above the helmet here, and the back horn is behind it, as you can kind of tell right there. So that was the setup, just to give me kind of a little bit more dimension in this cut. It's using a tapered ball nose through here, so there are some places where I couldn't get down very far through the wood, but it still, I think, turned out just fine. So I think it's going to be okay. If I was going to do it again, I might do like a sharper high angle V-bit, like or low angle rather, probably like a 5.4 degree V-bit between each of these grooves. But the tapered ball nose works pretty good. It's nice and smooth. So that's pretty much what the project looks like. Okay, guys, so let's talk about the toolpath here. My initial thought on this was that I would just create a 3D roughing toolpath followed by a 3D finish toolpath. Now I've got these labeled poor quality for a reason. I'll walk through that real quick. So the 3D roughing toolpath, let's just talk about that first. That's going to go over most of the face of the material, but it's I did set an outside circular vector because I'm going to profile this out as a circle. So profile cut that circle, but it's a pretty rough cut. It doesn't go all the way to the full depth, and that's by design. You want to leave a little bit of material for the finish quality, or the finish cut to take out for the best quality. So 3D roughing, really nothing wrong with this. I mean, it's pretty straightforward. I think it's kind of doing what I would expect it to do, so no issues there. But then if we go to the 3D finish cut here, we'll just look at what we're doing. I have a O-flute up spiral. It's 1/4 inch. I believe this was the let's see. Yeah, it's a 1/4 inch diameter. So I was kind of experimenting with some different values here, but we have a 40% step over. So it's going to be 1/8 of an inch step over. It's not roughly. I mean, it's not going to be real clean, and you can see that when we run it. And I was fine with that. Like, it's going to go all the way around these areas here and clear out all of this area. That was the intention anyways, clear out all of this area that's flat in between here and there, and here and there, all the flat areas. Anyway, in a lot of cases it's going to run up against the edge of the 3D model. So let's just see what this looks like. This is the clear cut. Okay, so I mean, you can kind of see that's exactly what it's going to do. It's going to clear cut everything. When you run up against the edge of the 3D model right here, you're not going to be producing a nice smooth edge on there. So let's see what that looks like here. We're just going to preview this. Sorry, I'm still getting used to the version 12 interface here. Reset the preview, and let's just preview. Let's actually do the 3D roughing and then the 3D finish, what I call poor quality, and we'll preview those visible toolpaths here. Okay, so as you can see, you can see it right here. It's got like lots of jaggedy. It's going to basically move the drill bit, and you're going to get rounded grooves all along the edge of that. I mean, it makes sense. Like, that's the way a clearance is going to work. You're trying to get as close to the model as you can, and it's going to create grooves. Okay, no problem with that. I was thinking though, and you can really see it right here, right? I was thinking if the finish clear, as this is called, the clearing pass of the finish quality toolpath is going to do that, then the final, smooth finishing path should go along the same walls and clean that up, but it doesn't. So that's the problem I ran into. You can see here the finish actually just calculates over places where that didn't touch, which I thought was a little odd, because that means for this to really create nice smooth edges here, then I would have had to run this at like a 4% step over, just so I get, so I get a nice smooth edge all the way across here. That's kind of defeating the point of having a clearance path to me. I mean, the main reason for me to have that is to clear the base, or the foundation of my material, not the edges. Okay, so I want it to have a wide step over just because it's a flat bit on the bottom. It's an end mill, so to me it kind of made sense that you would have the clear cut, clear out all this material out here, leave some grooves in the side of the model, and then along come the final finish, and it would clean up the outside edges of the model. But it doesn't do that. And I contacted Vectric about this, and they really didn't give me an answer on why it's doing that. They gave me some other suggestions on how to approach this. The way I ended up doing it, and before we even go any further, let me just say I'm using the material boundary for that. So like we're using the entire material boundary. There wasn't like a boundary around here that was getting cropped, and that's why it wasn't cutting the edges of it or anything like that. So it's just the algorithm, however they're doing this, is in my opinion, it's not really accurate. I think it ought to behave better than that. But as I guess an alternative to that, I went and created a 3D finish. So I still have the roughing that it gets applied, but then I'm going to do a finish instead. And for this one, let's go ahead and look at what that's going to do. I basically created a vector all the way around the outside of the model, but just gave it a little bit of extra, offset space here. So I didn't have to run this tapered ball nose over all of this material all through here. Like, I don't want to do that. That's a waste of time. And it's not good for the bit in the long term. So I want to use the bit as little as possible. So I made a path just right outside the model, and I didn't set up a clearance tool. I just have the tapered ball nose, and then the vector is it's this vector that I created over here. Let me show you. It's this vector right here. So it goes around the model. I think that was probably obvious, but anyway, so this works for the most part, except that I have to cut it this depth exactly the same as this depth. Now this depth is a little higher in the rough cut, so that means I have to add another pocket to clean out everything outside of that vector. Okay, so and then this cut depth is honestly, like, I just move the mouse over this area in the 3D preview. So if we previewed this again, I just move the mouse in this area, and you can see the XYZ coordinate in the bottom corner. I just said, oh, it's minus 0.405. So that's what we're going to cut this to. And yes, it pretty much, I guess it's within the tolerances of the bits and everything. It pretty much cut a smooth transition between here and there. It was no problem. Actually looked okay. So it works. Not the greatest though, because it's another bit change. But that was the issue I ran into. And then the last thing I have is just a profile cut around the outside with some tabs on the outsides here. So anyway, let's get to the cut and see what it looked like during the full process. Okay, so here we are just getting the board ready. We're gonna just double check that it's flat. Make sure that we get the clamps put in, attached properly, and then we'll get this thing kicked off. We're going to swap out this bit and then get this going. So we'll go ahead and do it all home. Wants to move. There we go. Actually, before I do that, I am going to set up the X and Y origin. And the way I like to do that is to position a sharp drill bit, like I've got in there now, a sharp bit over the corner of the board just to give me a good X and Y zero origin. So let's do that. Okay, X and Y is set for my origin, and then we will swap out this bit. Oh, one other thing I like to do is just run the bit along the edge. Not that edge. Let's go back to origin. I like to run the bit along the edge just so I can see it. Make sure it's fairly level, fairly straight, rather. Okay. Let's go back to origin. And then we're going to swap that bit out. Put in our first bit, which is going to be a end mill to do the 3D roughing pass. Save that because I'm going to use it later. In the drawer. And this is the bit. I believe this is let's see, it's either a Freud or a Mana. I believe it's a, yeah, it's an Amana 1/4 inch end mill. So we're gonna start with that. Now I like to get the bit up there as far as it can go without hitting anything on top, right? So I don't want to be grinding against any metal inside the sleeve, but I do want it to be up pretty high so that it reduces the flex in the bit, right? I mean, a longer bit is going to flex more left and right, or laterally, whatever you want to call it. So let's get that up pretty high in there. No need to over tighten that. The bit spins this way, and that's going to tighten itself, so we don't need to over tighten it. Alright, so now we just need to set the Z depth on that guy, so we'll just zoom in on that. Tighten this down first just so I get a nice accurate reading. We'll do the tool set on the B18 Rich Auto. And our first tool is set. We are ready to cut. Okay, so we got everything on our USB drive and we're ready to go. So we'll just plug that in. And we are going to run our program. So we go to run, and we're going to run it off of the disk, USB disk. And we're going to go V1. I number these. I usually just make them simple words. This doesn't show a lot of the file name, so we're doing V1 through V4. Now 3 of these use the same bit and mill, and then 1 uses the ball nose. So we've got the end mill in, and we're ready to start this up. We've got our VFD program to 300, or pretty close, 290. So that's around 18,000 RPM. I'll set that to 300 when we get going, so let's hit OK. We'll just leave it default work speed. Spin up, and we're ready to go. So that's what happens when you don't zero out the Z-axis on your second cut. Lesson learned. Slow down. Alright, we're all done with the first pass. That made a mess. Let's clean that up. For this one, we're going to use a tapered ball nose bit by Mana. We want to make sure that bit's not hot before we put it down. I don't want to lay it on its side when it's been heated up, because it'll warp side of the bit.
Oh wait, I lost the other black wrench, that's why I have to use my own husky wrench instead. Anyway, the bit's in good shape.
Let's go ahead and replace it with this one. Again, don't over tighten it, just get it snug. Get it tight, but don't go crazy on it. And oh, this would be a good time to show you the little fixture that I created to swap bits out. I didn't use it this time, but basically looks like this. So this just hangs over the nut area right here. And then you adjust this little set screw in the back, which I think I need a Allen wrench, so I'm not going to do it right now, but basically, well, it's already loose, so it goes up to the bit. That's as far as this one goes up, so it's not going to work on this one. But if the bit is long enough, you can adjust this to the height of the bit, and then you take your old bit out, you pop this off, take the old bit out, put your new bit in, you put this back on, you drop the new bit to the plane, to the floor here, and then you know it's exactly the same exact height as the previous bit, so you don't have to zero it out that way. Okay, this one we're going to zero, because it's fine. But that would save one extra step. All right, back to this one. We're going to go ahead and do our tool set. I always keep my finger on the cancel button because you never know when the wire or the ground might get lost to the machine or something might happen. And that bit will just keep on going down through that tool if you lose your connection to the machine. All right, we're ready for step 2. Alright, so that's the final product before we do the pocket. We're going to take a pocket and just clear out the rest of this material throughout here. And then we'll do a profile pass. That'll be it. Well, I forgot to set the starting depth of that pocket cut, so I just went ahead and canceled it. Went back, set the start depth. Should do the same thing. We're just cutting off that thin little bit of wood that's left right here, you know, in this area right here, all the way up to the model, all the way around. So let's get that going. Alright, so that was the final detail pass. It came out okay. There's a little bit of a edge right there, but I mean, it's honestly, it kind of just came off just rubbing on it, so I got it at almost exact same height that I needed it at. So I would say that's, yeah, actually worked better than I thought it would with the pocket. There's a little bit right there. I can kind of feel it across there. You can see it a little bit. It's that corner. But overall, I think it came out well. And now I'm just going to do the last profile cut here, just to cut it out into a circle, and then we'll mount it in my son's room. And that's it. It is complete. I put 3 tabs on there, so we'll just get that taken off and then vacuum it down and take a look at it here in a second.